Hi, today I'm going to talk about maximum and minimum on a interval extreme value. For the learning goal is to understand how the derivative can be used to determine the maximum and minimum value. Identify the extrema and analyze the endpoint. Before we start the topic, let's understand what is a turning point. A turning point happens when a derivative is equal to 0. So for this graph, we have two turning points. And how can we differentiate which is maximum, which point is minimum? So for a maximum point, it is the highest point in a graph, and for a minimum point is the lowest point in a graph. A function with unrestricted domain, a domain is all real number, which means it is from negative infinity to infinity. And a restricted domain is a domain from A and B, A to B. And A and B are also called as endpoint. An absolute or Gabler maximum or minimum is over the entire domain. For example, this graph, it is absolute minimum. It is absolute minimum is because it have the lowest point for the graph. And a relative or local maximum or minimum is over a neighborhood. For example, this graph, this is a local maximum. It is because the highest point for this graph is this endpoint. And this is the second highest. So it is a local maximum point. The maximum value of a function that has a derivative at all points in an interval occurs at a peak or an endpoint of the interval. The minimum value occurs at a valley or an endpoint. This is true no matter how many peaks and valleys the graph has in the interval. So an endpoint do not have a neighborhood, so it never be local maximum or minimum. So it only can be absolute maximum or minimum. Determine the maximum and minimum of the function of the given interval. Fx is equal to negative 2x cubed plus 12x plus 7, and the interval is negative 2 and 2. So for the first step, we will need to make the original function to a derivative function, which is negative 6x squared plus 12. And the second step is make the derivative function equal to 0. And when the derivative is equal to 0, we can get the x value is equal to positive and negative square root 2. After that, we need to check the x value, is it in the interval? If yes, we can move to the next step, which is make a table. And then we need to put all the value into the original function. And then for x equal to negative square root 2 and y equal to negative 4.31 is absolute or local minimum. It is because the endpoint are not the lowest point. So it is an absolute or local minimum. And then square root, when x equal to square root 2, y equal to 18.31 is absolute or local maximum. It is because the endpoints are lower than 18.31. So it is an absolute or local maximum. So I have made a graph to easier to understand the function. So we can easily see that this is the highest point and this is the end point. So square root 18.31 is an absolute local maximum, and negative square root 4.31 is a absolute local minimum. Find the extreme value of a function fx equal to x cubed minus 3x squared plus 2 on the interval negative 4 and 4. So the first step, we need to make it to derivative equation, which is 3x squared minus 6x. And then we need to make the derivative equal to 0 so that we can find the x. So x equal to 0 and x equal to 2. So after that, we can check, is it in the interval? Yes, okay. So we make a table, put in all the x value. This is the endpoint. We put the x value into the original function. Then we can get 4 points, which is when x equal to 0 and y equal to 2 is a local maximum. And when x equal to 2 and y equal to negative 2 is a local minimum, it is because the endpoint have the lowest point, so it is an absolute minimum. Always remember, endpoint cannot be local minimum or maximum. It only can be absolute minimum or maximum. And for x equal to 4 and y equal to 18 is absolute maximum. So we can easily see this from the graph. We can see the point from the graph. And we can easily see is it the absolute minimum or maximum. So we can see that 0, when x equal to 0 and y equal to 2 is a local maximum. And when x equal to 2 and y equal to negative 2 is a local minimum. Because this endpoint have the lowest point in the graph. So the amount of a current in amperes in an electrical system is given by the function Ct equal to negative 2t cubed plus 2t squared plus 16t, where t is the time in second and the interval is 0 and 3. So determine the times at which the current is at its maximum and minimum, and determine the amount of a current in the system at this time. So the first step is make the original equation to a derivative equation, which is negative 6t squared plus 4t plus 16. And then we make the derivative equal to 0 so that we can get the x value, which is x equal to -4 divided by 3 and x equal to 2. But we cannot use x equal to -4 divided by 3 is because time always is positive, it cannot be negative. After that, we make the table and then put the x value to the original function to find y. Then we can get the point when x equal to 2, y equal to 24 is an absolute and local maximum. And when x equal to 0 and y equal to 0 is an absolute minimum, because it is the lowest point in the graph. And when x equal to 3 and 12 is y. Okay, when x equal to 3, y equal to 12 is an endpoint, is because this point is higher than 3 when x equal to 3 and y equal to 12. But endpoint cannot be a local maximum or minimum, so it is an endpoint. We can easily see this from a graph. So 0, 0 is an absolute minimum, and negative and 2, 24 is an absolute or lower maximum because it is the highest. It is the highest peak. And 3 and 12 is an endpoint. Now I'm going to talk about the optimization problem. It is actually a mathematical modeling question. So a farmer with a 2,000 meters of fencing wants to enclose a rectangular plot that border on a straight highway. If the farmer does not fence the site along the highway, what is the largest area that can be enclosed? So we highlight the key point. We need to find the area, and this is a rectangular and 2,000 meters. So the first step is let's draw a rectangular. And then the area for rectangular is width times length. And the parameter for the rectangular is 2,000, so the length is 2,000 minus 2x, and the width is x. It's because 2x, yeah. And then we put in all the value into the area, so we can get 2,000x minus 2x squared. The area is 2,000x minus 2x squared. After that, we put this function, we make this function to a derivative function, so it will become 2,000 minus 4x. So we need to make the derivative equal to 0 so that we can get the x value, which is 500. So we just need to put the 500, the x value into the area, so that we can get the area is 50k meters. So that we can get the area is 500k meters. And then next, I'm going to talk about the optimization problem in economics and science. So this chapter will be harder than the normal optimized questions. A cylindrical chemical storage tank with a capacity of 1200 M cube is going to be constructed. The specification call for the base to be made of sheet steel that costs $5. The top to be made of sheet steel that costs $20, and the wall to be made of sheet steel that costs $15. Determine the proportion that minimize the cost of the steel for construction. So first step, let's draw a cylinder, and we know that the top is $20, wall is $15, and base is $5. And this measure is m squared, which means it is a surface area. We need to find the surface area for the cylinder. And this measure m cubed, which means we need to find this is a volume. So the volume for this cylinder is 1200 m cube. So a volume for cylinder formula is pi r square h. So we make it to 1200 equal to pi r square h, and h equal to 1200 divided by pi r square. And then we put the dollars into the surface area formula. So 20 pi r square plus 5 pi r square plus 15 pi r h, and equal to 25 pi r square plus 18,000 divided by r. And then we make it to derivative function. So it is equal to 50 pi r minus 18,000 r negative square. And then we make the derivative equal to 0, so it will become 50 pi r equal to 18,000 r negative square, so that we can get the r equal to 4.86. And then we put in the r into the h into the height formula, so we can get the height is 16.7. So the proportion that minimize the cost for the proportion that minimize the cost of the steel for construction is when r equal to 4.86 and h equal to 16.17. So the cost is $2097.63. So let's move to next question. A professional football team plays in arena that holds 22,000 spectators. Average attendance at each game has been 17,000. The average ticket price is $70, and market research show that for each $7 reduction in the ticket price, attendance increases by 800. Find the price that will maximize the revenue. So first step, we need to make a table about before and after. So the attendance is 17,000, and the ticket price is 70, and the revenue is the attendance time the ticket price, which is 119,000. And then we need to make a new formula for after. So we know that the attendance will increase by 800. So is the original attendance, which is 19,000 plus 800n. And then the ticket price is each $7 reduction, so is the original price minus $7 n. So firstly, we need to make it to the derivative equation, so it will become negative 63,000 minus 11200 n. And then we make the derivative equal to 0, so we can get the n is equal to negative 5.625. And then the price that will maximize revenue is 70 minus 7, negative 5.625, which is $109.375. And then the total revenue is 136,718.7.5. So let's move to the next question. A swimming pool is treated periodically to control the growth of bacteria. Suppose that T days after a treatment, the number of bacteria per cubic centimeters is n equal to 30T squared minus 240T plus 500. Determine the lowest number of bacteria during the first week after the treatment. So the first step is find the interval based on the given information, and we know that the lowest number of bacteria during the first week. So the interval is T greater or equal to 0 and less than or equal to 0. Then the second step is find the derivative of the equation of the original equation, which is 60T minus 240. And then we can make the derivative equal to 0 so that we can get the T. And T is equal to 4. And then we need to put all the T value into the original function so that we can know the lowest number of bacteria, which one is the lowest number of bacteria. So as a result, we find when T equal to 4, Y will equal to 20, which is the lowest number of bacteria during the first week, so is 20 bacteria per per cubic centimeter.